Hi everyone, good evening and thank you for being here to celebrate with us tonight. My name is Sepida Azargun, I'm an AIBC architect and I'm delighted to welcome you on behalf of Vancouver Persian architect community. Tonight is first and foremost celebration of Yalda night, a very special occasion for us Iranian and the heart of this gathering. Yalda, the longest night of the year, is about coming together, sharing warmth, poetry, music, and reminding ourselves that even after longest night, light always returns. There's truly no better way to celebrate than being surrounded by friends, colleagues, and community. As Hafiz beautifully remind us, بیا تا گل برافشانیم و می در ساغر اندازیم، فلک را سقف بشکافیم و طرحی نو در اندازیم. اگر غم لشکر انگیزد که خون عاشقان ریزد، من و ساقی به هم تازیم و بنیادش براندازیم. In sense, Hafiz invites us to celebrate together, lift one another's spirit and create joy, even in challenging times. That spirit truly sets the tone for tonight. For those of you who may not know us, the Vancouver Persian Architects Community began in 2008 with a simple goal to bring Iranian architects and design professionals together, support one another, share knowledge, and let's be honest, occasionally complain about architectural deadlines in Farsi. What started as a small group has grown into a community over 800 members. Yes, 800. Now at this point, if we all gather in one place, we probably need to book the Rogers Arena. Over the years, the community has become a space where people exchange resources, ask questions, celebrate achievement, and sometimes send messages at 2 a.m. to ask about CACB process. It has truly become a professional family. That sense of community is exactly what why tonight is so special. Alongside celebrating Yalda, we are also here for a series of insightful talks focused on important topic, the planning, design, and delivery of healthcare facility. These are spaces that impact us all, and the designing of them require thoughtful balance, creativity, technical expertise, coordination, and of course, patience. Tonight's program started as follows. The speaker's presentation will begin shortly. Q&A session will follow after that, and then we'll have around 15 minutes to answer your questions. Just housekeeping note, if you can keep your questions for the end, that will be appreciated. And if you need a sticky note to write your questions, our volunteers can hand to you. It is now my pleasure to introduce our panelists who have generously agreed to share their expertise, insights, and perspective with us this evening. I'll start with Roozbeh. Roozbeh is a healthcare project manager, real estate developer, and investor with over 15 years of experience delivering construction and infrastructure projects across Canada. He holds a master's degree in material science and engineering, along with formal training in project management. He has contributed to major healthcare projects, including the Burnaby Hospital redevelopment, the hybrid opening room at Abbotsford Regional Hospital, and the Queen's Park Long-Term Care Center. Earlier in his career, he managed large and technically complex projects within the construction sector. Roozbeh is also the founder of Roos Group, a private investment firm focused on healthcare and community-based development, and is passionate about mentoring and supporting emerging professionals in the healthcare and built environment sector. Roozbeh. I'm going to go to introduce all the panelists, and then they can start their presentation after. Next panelist, Bita Ardebili, brings over 25 years of experience in architecture with more than 15 years dedicated to healthcare and industrial projects. She holds a master's degree in architecture and certificate healthcare facility planning and design. Bita has worked on numerous healthcare projects across Canada and United States, and currently serves as a healthcare practice lead, focusing on functional programming, clinical planning, and the design delivery of hospital renovations and new healthcare facilities. Next, Behnaz Shirkat. Thank you for reminding me. Behnaz completed her architectural education in Iran University of Science and Technology and brings over 15 years of experience as a registered architect, AIBC, and a senior project manager. Her work spans facility planning, design, and construction for complex healthcare, institutional, and civic projects across both public and private sectors. She has contributed to a range of respected consulting, architectural, and multiple organizations, and currently serves as a senior project manager within the healthcare sector. In parallel with her professional roles, Behnaz leads her own practice, Besh Architecture Counseling, if I'm correct, if I'm pronouncing it right, focuses on creating mindful spaces that supports wellness. Last but not least, Mahmoud Sahari, who probably a lot of you know him very well, holds a master's degree in architectural engineering and brings over 35 years of experience as a designer, project manager, and builder, specializing in healthcare facility. He is particularly known for his deep technical expertise and hands-on experience in medical imaging center, especially MRI facility, where design coordination and execution must align at the highest technical level. He is also a graduate from Shahid Beheshti University. Okay, so I'll hand on the mic to our first presenter, Rouzbeh.
خوبه. فقط ببخشید چجوری بیارمش روی چیز؟ So first of all, I just wanted to say. Yeah. Okay.
I'm so sorry. I forgot one of our panels, which is on the honest one. So Farshad Jamali, he's an associate senior healthcare architect and senior medical planner, over 18 years of experience. He's a registered architect and evidence-based design certified professional. His work spans healthcare, commercial, residential, and complex renovation projects, and he has played a key role in major healthcare development across British Columbia, including hospital expansion, MRI suites, and emergency department renovations. Thank you.
Thank you very much. First of all, I just wanted to say a quick note. Thank you to VPA for inviting us here. It's really an honor to be among you guys, all the talented people. I see some very experienced people among the audience, so it's a pleasure really to be here. So obviously today's presentation is, we're going to be talking about how healthcare project is basically delivered, especially in Canada. When you talk about healthcare project or hospital, a lot of the people think about doctors, patients, nurses, but really very few people think about what it takes to deliver that healthcare facility or what's behind the scene. Healthcare projects doesn't really start with design, definitely doesn't start with construction. It usually starts with a need. And it's a long journey turning that needs to a functioning, safe facility. Today, I, along with my friends Behnaz, Pita, Farshad, and Mahmoud, we're going to provide a high-level view of the delivery process of a healthcare facility here in Canada. So why hospital projects, or when I say hospital, I'm generally talking about the healthcare project. And you're gonna notice during my presentation, sometimes I kind of like pivot from hospital to clinics or other type of healthcare projects. So excuse, I don't really want to confuse the audience, but you know, it's really very hard to be very comprehensive in this short amount of time, so I just try to be as efficient as I can be. But why, generally speaking, hospitals or healthcare projects are different? First of all, they're 24/7, so there is no downtime or there is no after-hour work, so they're constantly working. So when you're designing a healthcare facility, you just have to make sure that it's going to be up and running all the time. You cannot say that the HVAC system is not working, for example, for 4 hours in an operating room. It cannot be like that. The other thing is as you can see, there are many moving parts involved, like infection prevention control. When you're doing a healthcare project, so even a small amount of dust can cause a very huge problem in some departments. For example, in like a pharmacy or compounding department in hospitals, they are dealing with making different type of like compounds for, say, cancer patients. So you just have to be very careful about all the details. Hospitals these days are not just a building. They are very high-tech facilities. We are talking about like very advanced medical imaging systems, IT, and all of those, with this, especially AI, in the new hospitals. They are like smart buildings. The other thing is critical flow. So for the hospital, as you know, when you walk into a hospital, you see that patients moving, doctors moving, nurses moving, equipment's moving, so it's constantly things and items are moving, but you just need to make sure that they don't cross paths. So that's another consideration. And as I said, again, there is zero downtime, not only in the operation, like in the entire system. So the big misconception is a lot of people think that when we say hospital, it starts with a design. It doesn't. Usually, it's very simple. A need for a project, a healthcare project, usually resulted from a very basic needs. For example, just as an example. So. We recently, you probably have heard that in the news. So there is a need for new emergency rooms in Lower Mainland. So when a need is there, so us, because I'm working for Fraser Health as a public sector, like I said, my intent is basically just to talk a little bit high level on from this side of the table, like a public sector. My friends, they're gonna get into the more detailed design and process and all of that. But for us, when we hear there is a need, when we see something in the news, we feel like, okay, there is a need. We need to have probably another or extra ER room in Surrey area. So first thing first, we need to verify that that need is real. So we start with a very basic but important question. Is there really a need? Is it vital? Is it feasible? So we start that process with a feasibility study. So we have to go to, for example, Surrey area, go into the hospital, clinics, and ask the staffs, like emerge doctors, what's your wait time? What's the benchmark for the wait time, like international wait time, from the time a patient get into the triage to the time that the doctor is visited by a doctor. Say if the benchmark in Canada is, for example, an hour, sometimes you see that probably many of you have faced that the wait time is 8 hours in Surrey Memorial for emergency rooms. So sure, there is a need. So once the need is confirmed, then we have to get to the next level, which is a clinical service planning. So clinical service planning, basically, it's a document. So we go to the, in an example of emergency room, we go to the nurses and doctors and ask them, so what's the process? What's the steps from the time a patient get into the emergency all the way to the discharge? They explain all the process, because I, as a project manager, I'm not a clinician, so I'm not a doctor, I'm not a nurse. I have to understand what exactly is their language. And based on that, there's another steps, we call it functional program. So kind of like from here, we kind of like get into the design steps. The functional program is a document that kind of like transfer the clinical language into the design document, or into the design language. So for example, in functional program, so I go one step back. Clinical planning is a document that the emergency doctor says that there are these steps the patient needs to get into the triage. We take his temperature and all the vitals, then we send him to the waiting room, and he explains all the steps. In the functional program, our planning experts start defining that how large should be a triage. How many patients we can fit into the waiting room? How large is the waiting room? And then where the doctor is going to sit? How large is their office? And all of that. So we get to it's still not a design, but it's like a document talking about like the size of the room, the flows and all of that, the connections and all of that. After that, we get to a high-level concept design. We go to you guys, the architects, and give you the functional program and the clinical services plan, and you guys, based on your expertise, start designing a very high-level schematic design for that project. And after that, for major projects, we are talking about like anything over $5-10 million projects, we have to have a business plan approved by the Ministry of Health. Here, it's health is public, so you have to get approval for that. So based on that high-level schematic design, we're going to say that this project is going to cost $10 million. Once the approval is confirmed, then we get to the next phases. No approval, no funding, no project, right? And after that, we have the detailed design, and then we get to the next phases, which is construction, implementation, and activations. So a quick overview of the governance and stakeholders, like who are the players in our healthcare system. So on top, we have health authorities in BC, we have Fraser Health and Vancouver Coastal Health. Anything from Burnaby all the way to Abbotsford is under Fraser Health portfolio. Vancouver, Richmond, all the way to the up north is part of the VCH. So there are only two bodies, very integrated, sometimes working together. The other player, obviously the architects and other disciplines like M&E, mechanical, electrical, structures. The other player have significant role are clinical staffs. When you're doing a operation room, you cannot design something without involving the surgeons, right? Or the nurses. So these are the clinical staff, but it doesn't end here. So when you are in a hospital, there are other people involved. So infection control is a big part. For example, after the COVID, it's even more important. So you have to make sure that you're following the infection control guidelines when you're designing. People who are doing healthcare, they're pretty much familiar with this one. And obviously construction bodies that they're doing the constructions. And once the project is done, it's handed over to the facilities team. So hospitals are like factories. So you have a big team just taking care of the facility, like the HVAC, the electrical system, and all of that. So it's kind of like a system. And last but not the least, so far, how I'm doing on time? Good? Okay. So far I was talking about what gets built and why gets built. I told you it usually starts from a need and go all the way. This slide, it talks about a little bit how it gets built. There are different models contractually that you can build a healthcare project depending on the complexity of the project, depending on the scope of the project, and how immediate or imminent the need is. Design be built, I'm sure that a lot of you, they're pretty familiar with this one. It's a very standard model. What does it mean? The architects and other disciplines, they design the project, and the GCs, general contractors, hire to build the project. So this is a design be build. Usually used for where the scope is very clear, the risk is very high. For example, you are building a small room or an addition to a waiting area or something like that. Scope very clear. It's not a risky project. So you hire an architect, they design the project, and then you go to the tender, hire your contractor, and they build the project for you. The other model is CM, or construction management. Most of our projects are not that clear, so there are a lot layers of complexity, so we go to the construction management. The construction management is, there is more collaboration involved. For example, I'm currently building a hybrid OR in Abbotsford. So it's not that I only go to the architect and ask them, hey guys, can you design this for me? That's not how it works. There are lots of unknowns, they don't know that, and there are lots of complexity. So you cannot, for example, go into the hospital and to the OR room like اتاق عمل, when you do the operations and everything. So you cannot just get into that and start doing your demolition. It's up and running. You cannot say, wait, we are doing construction, do your operation, all of that. So in the construction management, we bring in the contractor and architects very early on. They started collaborating. Architect asked the construction, hey, if I build it this way or that way, what's going to be the impact on your construction? So usually used for more complex projects, and then there is phase involved. Design build, again, when you wanted to fast track something. We have this firefighter approach in BC, so when there is a problem, so they just say, hey, go and fix it. So it's very common design build project is whoever is hired to do the design all the way to the build. So the good thing is fast, so it's not that architect design it and then you go to the tender and then build it. It happens by same team or same company. More advanced one is P3, usually used for building new hospitals. So it's a more advanced, it's called private-public partnership. So for example, there are some P3 projects, Abbotsford Hospital is one of them. Say that I'm a private investor, I wanted to invest in healthcare and the ministry also wants to support this project. They're like, hey, let's build this project. We build the project, you operate the project, and they they split the profit kind of thing. It's more complex than that, but in high level. And IPD, Farshad and Bita, they are very experienced in this one. Very new model, very interesting and exciting, lots of layers of complexity, but it's like a partnership. So you wanted to build it's exactly like a partnership. Say that you wanted to build a hospital and you ask your chef, your manager, your investor, all to create a company, start a restaurant, and if it's profitable, they all take a profit out of it. If it's not profitable, they all involve in the downside of the business. Same thing for that. So the architectural firm, the GC firm, and the ministry, they just form like literally a partnership, like a company. They have a percentages in that company, and they go through the project. If it turns out to be profitable, good for all. If not, everybody takes the risk. So with that, and thanks for your patience, and if I was speaking so rapidly, with that I'm gonna hand it over to Farshad, more talking about the master planning and site. Thanks everyone.
اینو لازمه؟ بسیار سلام به همگی. So we have agreed to do this in English, so I'm going to just continue in English. So what I'm going to touch on today is the higher level of how what Ruzbe talked about starts to become a building, like how do we mass it, what are the things that impact siting of a hospital, how you locate it, and how you start shaping it like a sculptor. So I jump right into it. So when you receive that functional program that has all the departments and rooms in it, and the relationship of the departments, one of the first few questions that you ask yourself is, okay, this new hospital they want it has like 30 departments in it. Okay, which departments are at grade? Which ones are like literally they need access from, like they would be level 1, and like emergency department or certain cancer departments that have like heavy radiation bunkers in them or whatever, or logistics or kitchen or public lobby or whatever. Yes, okay. So those, so you ask yourself, okay, what are those departments? And then the next thing you ask yourself is that, okay, so that functional program gives me a list of rooms with their areas. So this emergency department has this many treatment bays, a trauma zone, a triage zone or whatever, mental health, behavioral mental health portion. What is the total area? And then what comes into play is the grossing factor, which for different departments, that is the level of inefficiency that is involved, like because you have to have these 2.4 meter wide corridors for stretchers to be able to pass beside each other. So all of that brings inefficiency. And in a hospital, depending on which department it is, you have an inefficiency of around 1.2 for office areas, 1.1, 1.2, all the way to 1.65, 1.7 for very departments that are very involved, like emergency or operating rooms or like surgical and the like. So where do you get that grossing factor? That is where it's important that you're working, like there's not too many hands in this town that they design hospitals. That's like one of the tricks. That's where one of the tricks is you got to be able to compete with the other team. So you gotta design a smaller hospital, so it's not very costly. You look at your bench, your previous projects, what were the grossing factors for certain departments? You multiply the number, the area that they gave you in the functional program by that number, average, kind of what type of hospital was it or whatever, and then you come to a total area. Now, with the specific departments that have to be at grade, now with multiplication of grossing factor, you have the total area of the first floor of your hospital figured out, more or less. Now, another thing that plays a big role at the very get-go is, if it is a new hospital specifically, is there a future phase defined for this? And does the client, are they expecting a new future phase? And is it very well defined? Could it be challenged? Is it realistic? And questions like that. And those are one of the first questions. Literally, I have to hold it here, right here. Yeah. So those are the questions you gotta ask the client very early on and challenge them on their program that they have now for the future phase. Another thing is that, especially if it is at the competition stage, you should not be scared of challenging the so-called important rules that they have, because they give you this booklet of 3,000 pages of project requirements, okay, which we call it a statement of requirements, or SOR. And that 3,000 pager, well, it has a number of clauses. Now you can give your drawing in 5 years from now, you probably can give your drawing to an AI app and ask, does my design meet the SOR? And but unless you give weight to which clause is more important than the other clause, you're not gonna get a good analysis. Now, you're gonna read fast through the 3,000 pager at the get-go, understand the rules, and in your first collaborative meeting with the client, you gotta ask, okay, is this thing that you have, that the entrance to the hospital should be from the east, is that really important? You know what I'm exactly talking about, yeah? Because she was on the other side. She has written the 3,000 pages. So, and they wanted it from the east. And we challenged it, but we didn't RFI the thing till the very last moment, no matter how many times Beta and her friends asked, can you RFI request for a change? And we didn't intentionally, because we wanted the other team to have the entrance from the east, take it literal, and we were gonna take the risk and not do it from the east because it just didn't make sense. So that you got to be willing to challenge the rules. Now, next is the normal things with any building. Okay, what is my zoning? What is my height restrictions? Let's say somewhere, it's not always the authority having jurisdiction, the city that tells you what are the limitations. It's because it's a government building, it's higher level of governance. So sometimes there are things like in Richmond, for example, you have the issue with airplanes coming to the airport. Yeah, so the height restriction is governed by that too. Now, so you find the setbacks and all that. Okay, that's the future phase, and then you gotta start understanding what are the access requirements that I have. Okay, so if I have my emergency department, let's say there, and the public entrance over there, so that's the people walk in there, but the emergency department has a walk-in and it has the ambulance access. Okay, so, and do I have a cancer program? What is the access for that one? And so that starts to shape your thing. One of the ones that normally clinical planners or medical planners are I don't want to deal with that one, is the logistics and where the trucks go and how the trucks get to the back of house end of the thing, because if the tail end doesn't work, like a human being, if the tail end doesn't work, you end up in the emergency room and they got to do a surgery on you. So if the truck radius, turning radii doesn't work to get to that back end, then nothing is working really. And that can take a lot of like how that thing circulates and how public versus service access is very important. And one funny thing that could be really at play is how do I do my equipment replacement down the road? So there are few very important heavy equipment like the MRI machine, which Dr. Saadi, you are going to talk about later. Like, how are you going to replace it? Let's say my MRI is on level 3 on here at that corner, and that is the ambulance entry into the emergency room. Now a big crane is going to stop there 15 years from now to just bring that magnet out and bring it down, put the new one in. You cannot close all of that. It's an emergency department. Not even for a short amount of time. So that becomes important suddenly, what happens 15 years down the road. Now that was a little bit ground up. When you figured out your first floor with the access and all that, there is a little bit of a top down that you need to do, especially in new, bigger hospital facility. So, and that is like, you guys have seen like a hospital has this podium portion, which is where the emergency, medical imaging, and surgical floor and all that are. And then there's this tower that is kind of set back, and that is where the patient rooms are. So the shape of that inpatient tower, is it an H? Is it like that's an H, for example? Is it a X? Is it a T? Is it a capital L, Y, whatever? So that shape, depending on what the needs and the functional program, how many rooms they wanted, and what was their staffing model, you come to the shape of that. Now, next is what are the service room requirements in this hospital? One of the recent ones that I worked on, which was from Fraser Health, and Bito was on the other side of the table, there was this requirement for all the service rooms across the whole hospital. They have to stack vertically, completely. Like a floor electrical room on level 2 with a floor electrical room on level 8 has to completely stack. And there should be no wet space next to none of them. Communication rooms and electrical rooms should not be next to each other. None of them should be next to a shaft. None of them should be next to a shear wall. None of them should be next to a stair. None of them should be, I was like, and the communication rooms should be beside 2 corridors because they need access in the ceiling to get the cable trays out, you know, like for the risk of what if there's fire in this. Anyway, so it was, you're suddenly dealing with a building that doesn't have 10 elevators. It has like 30 elevators, and some of them are like half the size of this room, elevator type. And you're passing this room like a sword through the hospital, and it's going through the surgical floor, emergency floor, medical imaging floor. Some of these floors have typical rooms in them, like treatment rooms that have to be all 3 meter wide and 3 meter by 4 meter or whatever, or it's suddenly a 65 square meter operating room. You cannot have a column in the middle. You cannot, it's just, you can't do any of that. So the whole coordination of these becomes an issue. So you gotta start challenging those rules. Okay, what if, Mr. Authority, what if Beta, that I kind of shift this room and this floor like a biddy, it has still overlap with the other one, is it okay? Or you start challenging the rules. Now, one of the funny ones is, where are my telecom rooms, telecommunication rooms? So the whole 80 meter, 90 meter cable reach for these rooms can become a real issue. So you gotta make sure you cover your whole building with where they are. And my own little way is to draw diamonds with like a radius of 80. Why? Not a circle, because the cable goes that way. It doesn't go wherever you want. It has to go through the corridors. Now, quickly, after you figured out the tower and the first floor, you're left with the balance of the departments in that 29 departments. Now it's like 16 of them left. So you look at their areas with the grossing factor, mental health, this and that, and like surgical, post-operation, and then you start looking at, okay, what are the critical adjacencies between some of them? Like surgical likes to be on the same floor as ICUs because when the guy is done operation, you don't want to put them in an elevator, take them to another floor, bring them out. Like it's not ideal. Or if they want to take them fast to an intervention like imaging room, medical imaging has to be adjacent to surgical. Now, and then you start looking at, okay, now at the same time, I don't want one floor to become very fat and the other floor become very small. So you got to start massaging this to put them kind of in a podium format. Now there are certain departments that become more important, like surgical floor. Surgical floor is duct heavy, so you normally want to put it underneath the mechanical room. So how recently a lot of facilities are being done is that like the emergency room and all the rest of it, there's few floors and then there's surgical floor and then there's this interstitial or mid-height mechanical room and then your inpatient tower starts. That is because the duct work that needs to get to the surgical is just right there in the ceiling, yeah? So it makes it easy. And then that MDR is medical reprocessing unit, which you will have an elevator between surgical clean elevator and soiled elevator, dirty elevator for, you know, so you gotta be careful that that is stacked with each other. So I talked about a good chunk of this one. And this is my last slide. So some of the some of the issues that can arise like early on, like I forgot to touch on this, is that when you go from that podium to the patient tower, there can be, depending on the soil quality of that lot, there can be issues structurally. Because if you have a mass that is suddenly becoming much smaller than the podium, it can act like a nail. So it has so you cannot just put that mass wherever you want because the mass eccentricity of that tower, it can cause issues. So there is this very intertwined back and forth, especially with structural engineer, mechanical engineer, very early on, that helps shape your building. And then that column grid, is it 9 by 9, 9.5 by 9.5? What is informing it? What are my parking requirements in the authority having jurisdiction in their parking bylaw? What is the size of some of my bigger rooms, like an operating room, okay, plus a certain area beside it, and the corridor? Can I fit in the same time my standardized rooms? So there is a lot that goes into it at the same time, and very fast in the design of it, you will figure out that really that last sentence, the devil is in the details, like that. And with that, like, I really want to hand it over to Bita because she will go into granular detail on some of this. Thank you. No, you just continue. Yeah. Do you have a use for this?
Okay, hi everyone. Thanks for having us here tonight. I'm just going to continue. Roosbe mentioned a project as a high level, how it starts and how it ends. Farsha talked about high level design of the building, how we're doing the blocking and stacking, and I'm going to talk about more detailed design when we start designing a healthcare building. So basically, the key elements of clinical planning. Clinical planning is really strategically designing a building to make sure that it does benefit the patients and the staffs in a hospital. That's called clinical planning. There are main elements to it. The first one is the workflow analysis. For me, that means the story of what's happening in the building. When I start designing a building, that's the first thing I ask all the users. I want them to tell me the story. When they go in the morning, what they do, what's their day like, what the patients do when they come into the space, how the material comes into the space, how they're servicing. So that's really the workflow analysis, how patients, staff, and materials move within the hospital. Functional programming, something that Roosbe mentioned. It's really defining the space needs in terms of how big they are and what are the adjacencies that we need for those spaces. We use it at the beginning of the project, but also as we go on, we keep using it. So sometimes the design gets back to the functional program and changes some of the items that we have in the functional program. For example, we say, oh, instead of 4 rooms, we need 5 rooms. So now we need to adjust the functional program. So we have it on our side as we are designing the building. Compliance and standards, we have very strict standards that we need to comply with for healthcare projects. Integration of technology, again, something that Ruzbe mentioned. We have smart hospitals now. We have smart beds. We have robotics in operating rooms. There is a lot of technology that you talked about telecom rooms that make these telecom rooms actually larger and larger, and very strict requirements that we need for them. And the most important one is the patient-centered design, which focuses really on the comfort, privacy, and safety of the patients. So what is patient-centered design? Really, patient-centered design comes from the idea and the philosophy of patient-centered care, meaning we put the patient in the center of a care delivery system. For example, as a cancer center patient, if you have a doctor appointment in a non-patient centered care, you go to an exam room, you see your doctor, then you go do your blood work, then you go to pharmacy to get your medication, then you have an appointment with the nutritional consultant or different type of care that you can get. A patient-centered care puts you in an exam room and brings all the care to you. So as you're there, the lab people will come and get your blood work. They make your appointment for your medical imaging. You get your nutritional advice, and everything happens around you. So based on the same philosophy, we have the patient-centered design, which puts the patient in the center of how we're designing. So when we design a patient-centered facility, we basically ask the patients about what their needs are, what they want. Our values are important to us. Even cultural background can be important. A hospital in Surrey might be very different from a hospital in St. Paul's Hospital, for example, downtown Vancouver. Different clients, different backgrounds, different values. So we really need to design based on that. And also, in addition to that, we have families and we have staff that can also help us achieve that patient-centered design. So patient-centered design has very good benefits. The outcomes can be shorter hospital stays, better experience for patients, family engagement. These all kind of reduce stress, increase safety, and for staff, it's operational efficiency, few medical errors, and improved staff satisfaction. And it's really important because we know that all of these shorter hospital stays, how important it is. There's a shortage of beds. There's emergency rooms that have long wait times. Staff retention is a huge problem for the health authorities. They get tired, they make errors. Patients have to stay in hospitals longer than usual. They move, they don't want to continue working the staff. So it's really important to really make sure that everything's in order and we can keep happy staff, basically happy staff, happy patients. So we need to make sure we can maintain that. I have kind of a bunch of words underneath here: ergonomics, security. These are one of the things that I love doing when I work on healthcare projects. Maybe my favorite thing the reason I'm working on a healthcare project is the number of people that are involved. And you mentioned that it's for a very small renovation, maybe 2 rooms. Sometimes you have 6 different user groups that are involved in the project. You can have people that are doing ergonomics, infection control, facilities maintenance, IMIT. So there are different groups of people, and as the projects get bigger, you might have a meeting with 80 people or 60 people, which is very interesting. And the key to really working these projects, for me personally, and I think you can apply it to any project, is really to listen. So I think you need to just step back. You're not an architect. You just need to understand what people want. And that's what I always do. Like, I just ask them, just tell me what you want. I have a lot of expertise. I know how an OR works. I know how an MDR works, but I want to know how they work. I want to know what they feel, what they want. So it's really listening to these big groups and hearing them out is really the key to a successful project. Okay, so I'm just gonna show you some quick sketches that I did. Very typical how we're starting to design a healthcare project at a higher level. Farshad talked about department stacking, blocking. So this is really more how a department is organized. I'm glad you talked about emergency departments because my slides are also emergency departments. This is an emergency department. The blue areas are all the basically zones that we have in an ED. You can see I have green arrows and I have red arrows. And I have green elevators and I have red elevators. Green is patient public access and red is staff access, which is my restricted access. We call this in a healthcare project a front of house and a back of house. So what's very important when we're designing a healthcare project, it's the operational flows and separation of flows. First of all, needing to understand how we're flowing through the building, how everything moves within the building, the one that I referred to before, and how we're separating the flows. We don't want to move boxes where the patients are moving. We don't want to move patients in back corridors where everything's not very clean and the walls are scratched. So basically we want to separate these flows. We also have the soiled and the clean flows that we need to keep separate. Cross-contamination is a huge problem. It can be a huge problem in a hospital, so we need to maintain that separation. So that's why in the sketch you can see the public and the patients will access the space from the front of house, and all the staff access is from the back of house, which also connects to the loading dock where Farshad was saying that truck access area, that's our loading dock. Another thing is the travel distance at a high level. A nurse typically walks around 40 to 50,000 steps in one shift, which is huge. It can cause a lot of fatigue for staff. So that's something we need to be really mindful about. When we're designing, we need to really think about staff and how we're affecting their work and their travel distances. Another item that is pretty big, especially became more important after COVID, is the outbreak control zones. If we have an outbreak, how are we controlling that? That's very important. So that's something that we do in inpatient units, we do in emergency departments. We make sure that we can separate a section of that department for an outbreak, which has design features that we need to add. We need to have a vestibule, and we need to have a hand hygiene sink. We need air pressure differential for that department. So we need to consider that. That's a huge item in designing a hospital. This is one zone in an emergency department with a care team station, the exam rooms, an ambulance entry, so staff flow, and a walk-in entry, so patient flow. And it is the same, so green is the patient flow or the front of house, and the red is the back of house or the staff flow. Things that are important here, some of the considerations are line of sight. We need to make sure that everyone's safe in the space. Line of sight can be for staff here in the care team station. As you can see, the way we have all the patient care areas, the staff anywhere in the care team station, they can see the entry to all the exam rooms, and they can also see the trauma rooms. So that's very important. Sometimes it's also important for staff safety. If they're in an exam room, for example, with a patient, and if the patient gets violent, we need to make sure that we have visibility to that space, and it's not in a quiet corner that they can be beaten up without anyone knowing. Other items are flexibility and adaptability, very important in healthcare. For example, emergency department after 8 p.m. might have reduced number of staff, reduced capacity. We need to design to consider this. We need to make sure that, for example, here, they can just use the right side of the emergency department, and just close out the rooms on the left. They can still use half of the care team station and these rooms and work with half the staff, basically. Accessibility, inclusivity is basically, I think, in any project now. We need to consider it in all projects. A bit more important in healthcare because we have aging population that use the hospitals. Colors, textures, lighting, it's very important for them. So we need to definitely consider that. Infection control, I think we touched on that, very important. We have private rooms now that help with infection control, also finishes and materials we're using in a hospital. And standardizing rooms, I think you touched on that too. Again, it's a trend that we're going towards more and more because we build muscle memory when we use a space. If we design all the exam rooms to be the same, as you go in, if you have a hand hygiene sink, the bed is in a corner, medical gases are on the wall in front of you, the workstations is on the left. If all the exam rooms are the same, the staff will build muscle memory. So when they go into the room, it's not always a new room layout for them. They know exactly where they wash their hands, where they see the patients, when they actually put their charging. So it actually creates safety for patients and for staff, less medical errors when you have standard rooms. So there are a lot of things that we can do really to achieve basically these concepts. This is a typical patient room. A typical inpatient room, it has a staff zone, a patient zone, and a family zone in the back. The windows are at the top, the main corridor is at the bottom, and there's an ensuite. This is a typical private patient room, which is what we have in all the new hospitals, no shared rooms. Just some of these strategies that we can have in this building or in this room, we can actually apply them to basically a lot of other spaces in a hospital, but I'm just going to mention them here. Make wayfinding intuitive and stress-free. When we go to a hospital, it's most of the time for a very stressful situation. It's not an easy feeling to go to a hospital. So we want to make sure that that stress is reduced. If we can help that with our design, we should do that. So basically, for example, if I have a corridor here, with having the doors this way, as you're walking down the corridor, you see the entry to the doors. So that's really helping with wayfinding. Wayfinding can also be signs, not only with words, with colors, with images, with graphic. We can help with wayfinding. Flood the building with natural light. Natural light is a healing element, really, so we should really take advantage of it. In the spaces that are important, no one cares if a storage room has a window, but it's very important if a patient care area has a window. Create a quiet, calm environment and private patient rooms. These are personal healing spaces. And that's why we have this private patient room, so you can see we have that space here. Welcoming and accommodating families, it's always a better experience if you can have someone you love with you when you're going to this stressful experience. And that's why the private patient rooms have the family zone, and that they can stay with them, help with the patients. Bring nature indoors. That's something I think, Behnaz, you will touch on that a little bit. It's biophilic design. Bringing elements of nature really helps with healing. That can be even pictures of nature in a room or windows to outside. Giving patients control over their environment. If you're in your room, if you can order your food, if you can control the lighting yourself, if you can easily go to the washroom by yourself without calling a nurse, these give you control. And that feels good when you're in a hospital. Prioritize safety and patient dignity, just making sure you have the privacy when you need to have it, and build supportive spaces for staff well-being. For example, just making sure that staff have access to see the patients inside the room, or they have a hand hygiene sink as they come into the room to make sure they wash their hands every time they go in or they leave. Just some of the concepts here. So really quickly, am I going over? No, okay. I'll go through this really quick. There's a lot of design standards that we need to comply with. Center for Health Design, it's a very good organization to, I'll give you a bit more detail about it. We have CSAs at 8,000, we have local health authority standards, and there are other American standards that we can use. We typically don't because it's a bit different from what we do here. Center for Health Design, it's really important. It's a nonprofit organization in the US that provides design tools based on research and evidence-based, basically. There are different ways that you can benefit from it. You can become an EDAC certified. That means that you do an exam, you get a certification, basically a kind of skill that you add to your portfolio as you're working on healthcare buildings. They have a lot of research, so they have access to research, and they actually can help you to do more research in terms of the effect of healthcare buildings, what we're designing, and then that can inform the design that you're doing. And then they have other tools. They have interactive design diagrams, safety risk assessment tools, and other tools. As an example, this is an interactive design diagram that they have on their website. They have different room types in a hospital. You can actually go and click on different items, and it will give you a list of how those items affect a patient or staff. And it's all based on research. So it will give you, for example, the furniture will reduce patient stress and anxiety. And if you click on this, it will give you actually the full research that was done and got to that outcome. CSA is at 1,000. This is a Canadian standard. It's nationally accepted. Mandatory in some provinces. I don't think in BC it's mandatory. We're using it. Oh, it is?
Just guidelines.
Oh, okay. So it is. And here in BC is, it's not. It's a guideline for us, yeah. But in some provinces, it is mandatory. It is, I call it the Bible for healthcare. For me, it's always beside me for everything you can refer to it. And it covers architecture, engineering, infection control, sustainability, accessibility, and safety. It really touches on every single space that you have in a hospital and other healthcare buildings like long-term care and other facilities. And then we have the local health authority standards. Fraser Health has a ton of different standards, going from how the workstations are laid out and how much distance we need between them, what's the height of shelving that we can have in our buildings, or the emergency washing facilities like emergency eye washes and showers that we typically have in hospitals, and a lot more standards that we're really using for our buildings. So basically, this is my section. I just give you a quick story. I was sick in June. I had pneumonia, and it took me 4 rounds of antibiotics, 3 hospital visits, 2 doctor visits, and 3 chest x-rays to recover. And it just being in the emergency department, it gave me a lot of insight. Like I was there were days that I was in a crappy patient bay. I could hear everyone around me. I knew why everyone was there, and that was not a good experience. And some days I was in a better patient bay and I had my privacy, I had my space, and it just felt much better to be in a hospital. So I just encourage you as architects, as designers, next time you're in a hospital or a healthcare facility, look at the features around you, and you can see if the space was just designed to really treat, or was it designed to really provide a holistic approach to patient healing. Thank you.
بزنیم بهتر میشه. ببخشید خیلی ممنون. مرسی.
Good evening, everyone. I wanted to initially apologize for my scrappy voice. I've got a lingering cold. I do my best to project, and I appreciate your patience. First of all, happy Yalda to everyone, and I'm very happy to present to you today a very emerging and impactful subject called neuroarchitecture, with focus on design for well-being in healthcare environments. As Bita touched on a little bit on patient-centered spaces, I'm gonna more talk about the details and what tools do we have to actually achieve this goal, and how we can use evidence-based science to provide more scientific approach to this, to our designs, basically. So the question is how the building itself can support well-being, and the answer, one of the answers is mindful architectures. As architects, we often focus on function, compliance, efficiency, and all the guidelines that are around designing a healthcare facility, especially that Bita and Farshad just touched on. But when people enter in a space, in all environments, especially healthcare facility, they feel it before they even understand it. So I'd like you to think how many times you've been into a place, whether it's a park, a housing projects, a mall, and you felt depressed and anxious, and or the opposite, happy and excited. We need to understand that every space communicates, waiting rooms, corridors, patient rooms. When stress is reduced through design, patients recover faster, staff perform better, and families feel supported. So we can literally design for calm to support healing instead of just leaving it to chance. And the duration of an exposure of individuals to physical environment can impact the effects. Like the effects that has on organisms, on perception and behavior. So in general, the longer you are in a space, the more you will feel the effects of the surrounding environment you are in. So that, without saying, that the longest you are in a space is a long-term environment, including hospitals, clinics, long-term care centers. These actually, we have, as designers and architects, we have to be more careful, and because we are generating more long-lasting effects in the brain. So what is neuroscience and where it meets the design? Recent neuroscience research shows that the brain continuously scans for safety, predictability, and social cues. Design that aligns with these principles can activate calming neural pathways, prefrontal cortex for focus, and amygdala for stress regulation. So this is called neuroarchitecture. the interdisciplinary science using evidence from the brain to guide design decisions. Neuroscience reveals various patterns of brain functioning, but people are still unique on account of influence of genetics, as Bita explained about a care center or a facility in Surrey is different from one in Vancouver. So because of that, the space has distinct effect on different people. Therefore, comprehending and understanding the target people who you're designing for is fundamental to the success application of the neuroarchitecture. How do we measure people's experience of the space? We now have some measuring tools that helps us to do so. Some of them are VR stimulations, eye tracking, EEG and heart rate monitoring. With advances in neuroscience, it is becoming easier every day to measure the indices to understand how brain waves behave in a space through biofeedback. For example, with an augmented reality glasses, we can show the project to the client in advance and measure their heart rate to understand their reaction when seeing the perspective. So these allow us to test emotional and physiological responses before construction begins. As mentioned, we now know that we can design spaces informed by evidence. So the next generation of healthcare architecture is data-driven and human-centered. We now have the tools to design spaces that regulates the body's natural biological rhythm. It's called the circadian rhythm, which regulates sleep, hormone production, mood, and immune function. In healthcare facilities, patients often experience disrupted sleep because of like artificial lighting, noise, or inconsistent schedules, like nurses coming in and out of the room, doing the test. And these disruptions can slow the recovery of the patients and increase stress. So by designing the patient's rooms and wards with access to natural light, considering light intensity, color temperature, and direction, we can reinforce the body's internal clock, supporting better sleep, alertness during the day, and overall recovery. And also staff areas can also benefit from daylight exposure during shifts. It improves alertness and reduces fatigue, contributing to better patient care and fewer errors. Waiting areas can also reduce stress and improve both patients' and families' satisfaction, as families of the patients are also often under a lot of stress for their loved ones, for sure. So if I want to name some key points that serve this purpose, it's to align windows and lighting to support day-night cycles. Use tunable lighting system that mimic natural daylight patterns and minimize artificial lighting at night in patient areas. We can categorize mindful healthcare design into 3 pillars. The 3 key application and design strategies are sensory regulation, cognitive ease, and emotional resonance. Each of these influences stress levels, recovery, and overall well-being. So let's now dive into each of these design strategies. Sensory regulation is about light, material, and sound. Patient rooms with daylight and outdoor views, acoustic zoning, and warm finishes help regulate the body and stress response. For example, in case of lighting, we need to observe how light enters into the space. The human body is more comfortable with natural light, but if a lot of artificial light is needed, what types of colors and intensity of the lamp could not cause glare. In case of acoustic, it's important to pay attention to the sound of the treatment environment and like the noise from the streets surrounding the building, disturbing concentration and sleep. And would it be necessary to use acoustic material? If it's a hospital which is a healing and treatment environment, perhaps colors play also a great factor. Colors like blue and orange are more interesting, and warm colors like orange and red bring excitement, while and movement, like cool colors like blue and green bring calm and serenity. We also know that color contrasts cause energy, and analogous colors cause comfort. So there must be a very strong study of chromatic composition to measure user satisfaction level. And all of these choices are measurable and impactful. Cognitive ease reduces mental load. What does actually help cognitive ease? Clear hierarchies, predictable spatial patterns, and sight lines to staff stations, as was mentioned earlier, makes space legible. This is especially important for patients and visitors who may be anxious and unfamiliar with the building. So in healthcare, wayfinding is critical. Confusing corridors, poor signage increase anxiety and cognitive load, while design clarity, predictable paths, visible exits, logical circulation reduces stress and enhance safety. We can use color coding, wayfinding zones, or some visual interest to our wayfinding design, as shown on some of these examples. The last of the three pillars is emotional resonance, which focus on human connection and dignity. Art, nature, texture, and scale create spaces that feel safe, comfortable, and welcoming. Even small design gestures can signal care and respect. An essential lever is biophilic design, which incorporates natural elements into the built environment and has been proven to be a key factor in enhancing well-being, particularly in healthcare. Seeking optimal sensory balance, avoiding both overstimulation and sensory deprivation brings calmness to users. So, as my final slide, I want to emphasize that every line, every material, every corridor matters. And architecture isn't just about efficiency, it can be a healing agent. We have the opportunity to design the spaces that improve well-being before medical intervention begins. Mindful architecture isn't just a style, it's actually a shift in our mindset. From floor plans to brain scans, from stress-reducing details to intuitive layouts, our work shape health outcomes. So let's embrace design as preventative healthcare. Thank you. I didn't cough at all.
Hello everyone, and happy Yalda night. My name is Mahmoud Saheli, and I want to talk about technology in healthcare facilities. And it's the most important area in any hospital or healthcare facilities is imaging department. We have in this department MRI, magnetic resonance imaging, CT scanner, X-ray, fluoroscopy, ultrasound, bone densitometry, mammography, and nuclear medicine, and some others. And the important of this device is MRI. How it's changed? Oh, no, it's too much. No. Yes. And I want to talk about the MRI story. It's very important, and I believe most of you doesn't know about that well. And ask you to stay until this evening, and you can find a little more knowledge about the MRI. Every MRI designer or architect knows about the MRI machine first. And for this, I listed some factors like magnet types, MRI basic, planning consideration, safety zoning, space design, shielding technical infrastructure, floor plans example, and MRI safety. And we have three major types in MRI. Permanent magnets, 17,000 to 90,000 kilogram. Resistive magnet, 3,500 to 4,500 kilogram. Superconductive magnet, 5,500 to 70,000 kilogram. And superconductive is common magnet recently used. And the basic of the MRI machine is high-tech diagnostic device that use strong magnet and radio wave to create detailed images of the inside of the body without any radiation, like X-ray. This process is made by a superconductive magnet. A strong electric current is applied and creates a very strong magnet field and very high temperature inside the magnet. For this reason, internal components are cooled with a liquid helium to approximately minus 269 centigrade. Using an MRI machine requires carefully safety measures, especially regarding a strong magnet field and preventing from external radio frequency signal interface. For this reason, we need radio frequency shielding and magnet shielding. And the most important thing is the magnet always stay on, even when the power supply disconnected. This is very important. Here you can see the magnet French field diagram. We have all surrounded of the magnet is magnet field. And very important for the architect and designer to know about 5 gauge line. And this red line is 5 gauge line, and you can see outside this is safe for public, and inside is need strict control, screening patient, and trained staff can only allow to enter the MRI room. For example, cardiac and neurosimulators are very unsafe in these 5 gauge, like a pacemaker inside the heart. And the magnet field strength unit is Tesla, and 10,000 gauss is 1 Tesla. And we have the superconductive MRI, common 1.5 Tesla is 50,000 gauss. And just that in the inside, in the center of the magnet here, and that place the patient body we put just on the center of the magnet. And the finding location for MRI is very important. For location, we must to know must be far 12 meters from small car route, 16 meters from truck route, 200 meters from railway or subway, 15 to 30 meters from power transformer. And inside of the plan, the hospital, we need to far away from the CT scanner, elevator, and something like that, like this. This is only for the outside of the MRI room. And for a structure, we need the floor bearing capacity for magnet 5 ton to 7 ton, plus RF cage and magnet shield weight, around 2 to 12 ton. And the height is very important. We need at least 3.5 meter. And we need to check the magnet axis. This is important, and you said about the displace the new magnet to old magnet. We need to check out before. And the most important thing is we need to see that for ACR recommended American College of Radiology for MRI suite, we have 4 zones in every MRI suite. So, zone 1, public areas, and is the outside of the MRI zone for waiting room, general corridors. And zone 2, interface between public and control area, like patient preparation, reception. Zone 3, restricted area controlled by MRI trained staff, like corridor room, corridor leading to the MRI. And zone 4 is inside of the MRI, and this is the highest risk zone due to the magnet field. And the goal is prevent ferromagnetic object, untrained individual, and unscreened patient from entering to the unsafe area. And for a structure, I only one slide here. For floor bearing, generally 1,000 to 1,500 kilograms per square meter when we design it. And also we need to check the floor for vibration and deflection. Is need to less than 0.2 to 0.5 millimeter per second RMS for optical image quality. If we have a vibration, the whole image is not good quality. For this reason, mostly we need to put reinforced concrete slab and isolation pads, separate concrete foundation, separate from the building foundation. And for space design, this is a code, and we need to magnet room, control room, equipment room, patient changing and preparation, holding patient recovery area, utility room, waiting area, and staff and doctor workstation. After the imaging provide the doctors here, this room is for analyze and preparing a report for the patient. Oh. And the magnet room size generally is 35 to 50 square meter, and MRI suite size 130 to 160 square meter. And we are going to shielding for that because we need to protection inside from the outer radio wave. Radio frequency shield for this we use with material copper, stainless steel, aluminum for protection room from outer radio frequency. And we need this shielding in 6 sides of the room, wall, ceiling, and floor. And RF door, we have a copper layer inside, and window also, we have a mesh inside of the 2 layers glasses. And the penetration panel is very important. We need to mechanical and electrical system pass from this penetration panel and no any wave into the MRI room. And also we have air in and air out waveguide. These are waveguides. Waveguides is a special frame to keep the waves and doesn't allow to come inside of the room. Like mesh we use in the windows. And also we need to exhaust waveguide. The other shield is magnet shield. The material is silicon steel and low carbon steel. This picture shows the magnet shield, and this for radio frequency shield. And we doesn't need with any part of the walls because we need to calculate which side it need for this because for magnet shield is go outside. I show later. Here you can find the layers of the magnet room. We have a room masonry, this or drywall, magnetic shield we need to put the wall, and airspace we need because we cannot contact any RF shield to the masonry or drywall. And you can see here we have an isolator to stand and support for the ceiling. And also RF shield 6 sides needs soundproofing layer because we have a sound, very high sound and continuous sound inside. And this sound is not good for patient and also for the staff. And interior finishing like the other rooms.
So which one is RF?
This RF shield, 6 sides. This RF shield and this layer RF shield is different. And here you can see in this orange, this RF shield. And inside we have a soundproof. Here you can see some detailed photos from this, and you can find here we have a dielectric isolator to support the main ceiling. And this is very interesting. We have some fingers here. This is the fingers in both sides, in the frame and also in the door. And just they keep each other and good connection for protect the waves inside. This helium vent pipe, this penetration panel, and all cable and pipe needs to go inside this, and the other side we don't have any wave. Here you can see vent pipe for helium, exhaust pipe, and this air in or air out waveguide. And here you can see a soundproofing layer. And this you can find a mesh inside of the windows. And so is the other kind of the soundproofing here. We keep it. This is two of my projects, and both is out of Iran, not in Iran. You can see the red line is 5 goes, and here the 5 goes is out of the room. It's very dangerous for the public. And unfortunately, here we have a public access. But sometimes, like here, we have a technical area, and doesn't matter because the stuff we can allow to inside. But here we put this green line is magnetic shield, and the 5 line is reduced to orange line. When we reduce this, we can put in the wall, and it doesn't dangerous anymore. And here you can see the blue color for RF shielding. Here the other colors is blue for vent pipe for helium inside of the magnet, and this around 3 by 3 meter for entering the magnet. We need to before consider about that. And here for vent air in and air out. And here we can see some hazards, and major hazards is powerful magnet field, and the others is quench, magnet quench. MRI magnet field is very strong, about 30,000 times stronger than Earth's magnet field, and need compliance with the MRI safety protocol. Magnet quench happens when the MRI magnet suddenly warms up and liquid helium inside instantly turns into gas and rapidly replaces oxygen in room. What happened? Patient will die. And here is new news. A 65-year-old man identified died after a heavy ferrous chain necklace he was wearing and was pulled into the MRI machine. It happened in July 2025 in New York. And for this reason, we have to put these signs, and you can see here for pacemaker, for any ferromagnetic tools, to people find it's not allowed inside of the room. And here you can see the vent pipe, and the quench moment in outside and quench moment inside is very dangerous. I don't know, I have a time more or not. Because this 2 video is interesting if we can use it. I don't know why it doesn't work. Oh, yeah. باید چیز بپرس.
I think before presenting you need to enable the voice.
Yes, I don't know.
You might need to escape it.
ویدیو تو این کار میکنه؟
آره صداش قطعه. آره صداش قطعه. باید صدا رو با این برسیم.
Identical or magnetic field effects, such as explosions, fire, or ferromagnetic projectiles. Cryogenic gases, if released, will quickly displace breathable air, helium rises and nitrogen falls when it's cold, then rises and mixes with the air.
دومی هم دو تاست. اون یکی چی؟
This reduces the amount of oxygen in the air to dangerously low levels. Most sites have oxygen monitors installed, and anyone servicing a magnet must use some form of oxygen monitoring. If you have any doubt about the air quality, don't enter the room. Liquid cryogens can liquefy oxygen in the atmosphere, producing a highly enriched oxygen liquid, which is also highly flammable. So smoking is prohibited in the magnet room and around any cryogens. A very serious situation can occur when some sort of problem causes the magnet's superconductive wires, which have been conducting current with no resistance, to become resistive and to heat up. When this happens, the main magnetic field quickly collapses and all the magnet's liquid helium boils off at a very rapid rate. This is called a quench. If the magnet's vent system fails during a quench, cryogens are released into the air, displacing the oxygen in the room and making it difficult or impossible to breathe. This is a potential. So with all this going on, just how strong is an MRI system's magnetic field? The magnetic force exerted on an object is a function of its mass or weight, its distance from the magnet, the field strength of the magnet, and its orientation to the magnetic field. In tests at GE Medical Systems, a 2-pound wrench 2.5 feet away from a 1.5 Tesla MR magnet was pulled toward the magnet with a force of 3.7 pounds. At 2 feet away, the magnetic force rose to 10.8 pounds. And at the magnet, the wrench was pulled with a force of more than 50 pounds. A rubber ball filled with steel shot illustrates the speed an object can attain as it heads into the magnet. But just as important is the rate of the ball's acceleration and the unpredictable direction it takes. When you look at all the factors, a large amount of electric current generating a magnetic field this strong, this broad, and this persistent, and with liquid helium and liquid nitrogen as integral parts of the system, there are obvious potential hazards to people and equipment in the area.
Thank you so much.
Thank you for listening and staying up to the end. I know a lot of you are coming from work and it takes patience. And just before moving to the fun part with the music and food and celebration of Yalda, I just wanted to give a big thank you to first of all our volunteers, which dedicated their time and effort to make this all happen. And a special thanks to Sima, which happens to be my sister, and also Mr. Saheli for they played a big role for this event, and also to our presenters that they gathered every week. I think you had meetings, and I was skipping those. Sorry. And then next would be our sponsor. We had first of all. Cosentino showroom that we are here. They have a beautiful showroom. It's our second time that we are here, and they have a very nice Cosentino family. They are a Spanish family supplying a leading supplier of all the solid surfaces. And Negin, who is one of their the big team members, you can stand up. If you have any question, you can definitely talk to her. She's very knowledgeable and can help you. And also another sponsor that we have tonight is Proxima Lighting, who Mr. Sasan, who is at the end. who are there, around for 30 years, who a lot of you may know them. And we have the honor that they've been sponsoring our events for several times now. Thank you so much. And we have ATA groups that are going to play music for us. And I'll let them introduce their team members. Thank you so much.